Hello, hello, and welcome to a little video about the KC6 test review. Let's get started. For number 1 and for number 2, what we're going to do is we're going to rewrite formulas in explicit form and in function form. Let's start off with explicit form. Now, the formula for explicit form is as follows. an equals a1 times r to the power of n minus 1. Okay, so a1 is our first term. That's easy to find. It's the first number. 1. Now, r is our pattern. So in order to find our pattern, I'm going to take the second term and divide it by the first term. -5 divided by 1 is -5. So -5 goes inside those parentheses. Voila, we have it. And of course, I need to do some color coding. You know me. There we go. Okay. Let's do the same thing for number 2 for the explicit formula here. Okay, so our first term is 1 again. Very nice. To find r, we have to take our second term and divide it by our first term. 4 divided by 1 is 4. Okay, so we have our r term. And then we write a little n minus 1 up here. Okay, next let's rewrite these explicit formulas into function form. Function form is f of x equals a r to the x. Now in order to find a, what we're going to do is in your calculator, you plug in your function with a 0 instead of n. Now the reason we do that is because 0 plugging in for n gives us the y-intercept, and that's what a is. A is our y-intercept. When I plug this into my calculator, I got -24. All right, -24. The r is the same as in the original, so it's 1/4 to the power of x. Let's do the same thing here. In order to find a, we're going to plug 0 into n because a is our y-intercept. Okay. When I plug this into my calculator, I get 4. Our r stays the same, so it's still 6 to the power of x. Okay, beautiful. Number 3. Let's compare these two exponential functions and see which one has the greatest common multiplier. Now the common multiplier is our r term. In function b, I can see that right away, it's 6. There it is. For function a, I'm going to have to do some division. Second term divided by first term. That means r, what is that going to equal? Oh, let's be consistent with our colors. Green. Green. R is going to equal 5. All right, function b has a bigger one. Let's do the same thing for number 4. We're going to divide second term by first term. 3 divided by 3/4 is 4. So r equals 4 here. And for function b, r is 8. Function b is our answer. Number 5. We're going to translate these functions. So if we're going to translate 100 units to the right, we rewrite our original function, and we're going to put a -100 in the exponent. For number 6, I'd like to move our function down 13. When we're moving up and down, our number, our movement, our translation does not go, up in the exponent. It goes outside of the function, -13. Number 7, translate the graph 6 units up. All right, let's use the points. Let's translate. Okay, so it looks like each unit is 2 boxes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And lastly, 1, 2, 3, 4, 5, 6. All right, there it is, translated 6 units up. Number 8, which of the functions model exponential decay? Now, exponential decay happens when inside of our parentheses, we either have a minus or a number less than 1. So, letter A, 1 minus 7.78. That's decay. Letter B, 1 plus 0.6. No, that's growth. So not letter B. Letter C, we have 1.93. That's growth. It's bigger than 1. Letter D is 0.99. That's less than 1, even though it's just a little less than 1. Letter D is also our answer. Number 9, Liz is considering depositing $2,630 into her account that pays compound interest. How much will be in her account if she receives 1.4% over 10 years? Okay, so the first thing we write down is how much money she's putting in. That's $2,630. If she is receiving means growing, so that's a 1 plus. I'm going to turn 1.4% into a decimal. I know it looks like a decimal, but it has a percent sign, so it's a percent. So I do 1.4 divided by 100, and I get 0.014, and that's what goes in here. The time we're looking for is 10 years, so 10 goes up here. All of this goes into your calculator, and you should get $3,022.28. Let's do the same thing for number 9. Now Liz is considering depositing $450 into an account that pays compound interest. How much will be in her account if she receives 3.5% compound interest for 5 years? Okay, she starts with $450. Beautiful. Beautiful. Whoops. Try that again. There we go. She's receiving again, so that's 1 plus. Receiving. 3.5% as a decimal. I'm going to do the same thing as I did for the previous one. I'll do 3.5 divided by 100. I get 0.035 to the power of 5 because 5 years. Plug this into your calculator. Oh boy, sorry, a little mucusy today. Plug this into your calculator, and you should get she has $534.46 in her account now. Number 11, the average attendance at a local high school was 875 students. Each year, the attendance decreases by 0.7%. What's the average attendance in 3 years? Okay, start in the same way. We start with 875 students. We are decreasing, so that's a decay function. So we're going to have 1 minus. 0.7 as a decimal, I get by doing 0.7 divided by 100, and that's 0.007. And we raise it to the power of 3 because we're looking for 3 school years. When I put this into my calculator, I get 856.75 students. I'm going to round up because we don't have 0.75 of a student. That's crazy. So 857. Number 12. A town has a population of 40,000 in 2005. The population has been decreasing by 11% each year. The graph shown models the relationship. Let's use the graph to estimate, that's the key word, estimate, when the population of the town was half of the one in 2005. In order to find half, we divide 40,000 by 2. That's 20,000. All right, let's find 20,000 on our graph. There it is. I'm going to draw a line out until it hits the curve. Well, that did not work. I started drawing my line downwards. Let's try that again. Follow the grid, Gumin. There we go. It hits it somewhere there. So it looks like it's between this 6 and this 8 that's labeled. You could write in a 7 if you'd like. I'm okay if you just use the numbers that are there. Okay, so it's between the 6 and... Actually, you know what? I changed my mind. I think I would prefer you to notice that this was at 7. So let's write that in. 7. Okay. So it's between these 2 years. Okay. Now, 6 and 7 aren't actual years. They are years since 2005. So we're going to write down 2005 plus 6 and 2005 plus 7. 2005 plus 6 is 2011, and plus 7 is 2012. So between the years 2011 and 2012, the population had half of what it did in 2005. Now, if you did give me 2013, if you use that 8 there, I don't think I would take off points, but try to read graphs a little better. Try to be a little bit more accurate with them. Okay? That's the review for KC6. If you have any questions, please make sure to ask me or whoever is helping you study. Otherwise, have a wonderful rest of whatever day it is for you. Bye!